Dear students, today we learn equations of motion by graphical method from velocity time graph. Velocity time graph. So there are three equations of motion. One is the v equal to u plus at. Second one is equal to ut plus half at square. Third one v square minus u square equal to 2as. So before derivation of these three equations, you should learn the two important points. The first one, the slope of velocity time graph will give the acceleration of an object. So what do you mean by slope here? Slope is nothing but a y-axis by x-axis here. You know very well from the graph, what is the y-axis here? Velocity, and x-axis will be what? Time. Velocity by time, what will get? So acceleration here. Velocity by time, acceleration. The second most is the area under velocity time graph gives the displacement. But here, area nothing but a here, y-axis into x-axis. Y-axis into x-axis. That is area, L into B like. So, velocity by velocity into time. Velocity nothing but a displacement by time. So, into time over here. So, time get cancelled. We'll get the displacement. So the second point will give the displacement area of the velocity time graph. Okay. So now we derive the from first equation of motion v equal to u plus at here. Okay. So from the velocity time graph you can observe O2a is the initial velocity u, and at a point A, the velocity will be changes, the accelerating, then the final velocity will reaches here V. That is the final velocity over, this is the V is the final velocity. And what part will be the changing over here? That BC part is the changing here, that should be V minus U. So this is initial velocity and final velocity and change in velocity BC. Okay, so from the definition of acceleration, what is the definition of acceleration? Change in velocity, rate of change in velocity, right? So A equal to change in velocity by time here. So what do you mean by change in velocity here? BC by AC here, A equal. So what is the BC over here? V minus U. AC nothing but a time interval T. Can do cross multiplication. AT equal to V minus U. Therefore, V equal to U plus AT. So this is the first equation of motion from VT graph. Okay, right. So now the second equation of motion from the area of the graph. What is the second equation of motion here? S equal to ut plus half at square. So here also this is the initial velocity and this will be the final velocity and this will be the change in velocity. So this is the change in velocity here, v minus u. So here say there are two areas we can observe. One is the rectangle area, you can observe from the graph, rectangular area, and one more is the triangular area. This is the triangular area. So that means we will get the displacement here, displacement here, area of rectangle plus area of triangle, area of triangle. So what is the area of rectangle here? OA into OD plus area of triangle of base nothing but a AC into BC over here. So S equal to OA nothing but a U, this will be into OD nothing but a time interval of, what is the AC over here? Time interval T, and BC will be V minus U. So should we write like UT plus half t into v minus u. The first equation of motion what? V equal to u plus at. From this v minus u is equal to at, you can write from that. So then write here at here, first equation of motion. Then s equal to ut plus half at square. So this is the second equation of motion from the velocity time graph. So, and the third equation of motion. What is the third equation of motion? V square minus u square equal to 2as. So we finding this equation from the area of trapezium. So area of trapezium, area of trapezium. So gives the displacement here. Gives the displacement, displacement. So therefore displacement equal to area of trapezium. Area of trapezium. What do you mean by area of trapezium here? Half h into a plus b here. Half h into a plus b. What is h? This is one height. This is the one side is a and another side is b here. So this is h nothing but a time t, a nothing but a u and b nothing but a v here. So s equal to, so it should be right half h nothing but a t and a plus b nothing but a u plus v. So from the first equation of motion, what is the first equation of motion? V minus u is equal to at. Then t equal to how you write v minus u by a. Then substitute here half t in place, right? V minus u by a. That is, can I write like u plus v into v plus u? A plus b, b plus a same, right? So then s equal to a plus b into a minus b, you know very well, a square minus b square. So here v square minus u square by 2a. So then you can do cross multiplication. 2as equal to v square minus u square. So therefore v square minus u square equal to 2as. So from the area of trapezium base. Okay. So now we'll get three equations of motion. V equal to u plus at one equation. Second one s equal to ut plus half at square. Third equation v square minus u square equal to 2as. So here u what here? U nothing but a initial velocity and v is the final velocity and t is the time interval and a is the acceleration, and s is the displacement here, displacement. Okay. Hope you understand these three equations. Thank you.